Okay, so whenever you're completing the square, the very main rule, which you wouldn't have seen in our previous lesson, you have to have it start with just a plain x squared. It can't have anything in front. So if you have something in front of your x squared, you're just going to take and divide every single term by that number. So in this case, I have a 2 in front of my x squared. You cannot do the process for completing the square unless you start with a plain x squared. Now, in this particular case, this is going to be very nice for us because all these numbers are divisible by 2. So this is going to become x squared plus 18x plus 130 equals 0. So this is actually going to turn out to be very similar to what we were doing the last time. Okay, now, I know it's been a little bit since we have done this. So to complete the square, what I would have you do, keep your squared term and your linear term. So the x squared and the x, keep those on the same side. I'm going to put plus and leave a little space to complete the square. And any plain number, I'm going to move to the other side. So for this question, it was positive 130. So if I move that, I would actually be subtracting that from both sides. So I'm going to have negative 130 on the other side. Now, the other thing I like to do, just to remind myself, when I complete the square, I'm going to add something to that left side. I have to do that same thing to the right side of the equation to keep the equation balanced. Okay, does anybody, just raise your hand, does anybody remember how, I find the number to complete the square? Yes. Yes, okay, so what would you do for this question? Perfect, 18 over 2 squared. Now, if you can, I might just think about, 18 divided by 2, right, is 9. So I'm going to square that. That's what I'm going to add to both sides. So that would be 81. Now, the reason I kind of like to write that out is because I promise you, whatever you square, that's going to be in your factor. The entire purpose of completing the square is to create a quadratic, which I got on the left side here, where the two factors are exactly the same, and we can squish them together. So multiply to get 81, add to get 18 would be what number? 9 and 9, right? So we write it as x plus 9 squared. And it's going to be a plus here. If this is positive, this will be positive. If this linear term is negative, this will be negative. And then on the other side, we actually just add 130, which is negative 130, and 81. And excellent, I got negative 49. Okay, now the entire purpose of doing this, when those two factors are the same and we can squish them together, that allows us to get rid of the squared by just taking the square root right then and there. Don't FOIL that out. Unless you're bored and you want extra work, we don't want that. Okay, just take the square root of both sides. That square root and squared cancel each other out, so you still do have x plus 9. Don't write plus 3. Okay, don't take the square root of 9. That's in the parentheses there, so that stays exactly the same. Okay, what is my square root for 7i? Good deal. Okay, just don't forget, if you introduce the square root, we're going to put that little plus and minus symbol because there's actually two answers. And in imaginary land, that's a perfect square. It's 7i. The only other thing you can do here to get your answer is we just need to move the 9 away from the x. So I would just recommend just write it right after the equal sign, negative 9 plus or minus 7i. That's actually two different answers. You cannot add negative 9 to 7i. We can't add real numbers and imaginary numbers together, so you can just leave your answer right like that. Is anybody having a question? Okay, now, honest and straightforward, the other questions in this are going to be like a little algebra heavy in terms of we're going to have some fractions and stuff, and it's not everyone's favorite, okay? But it's not bad, but you might want your calculator for this part just to help with the fractions a little bit. If you are going to complete the square, first thing I'm going to do real quick, I'm going to just move any plain numbers to the other side of the equation. So I'm just going to move that 3 real quick just to start this off. So just add 3. Now, the only time you can complete the square is if your quadratic term, the x squared, has to start with a 1. So this one starts with a 3. So if that's the case, we're just going to do one step before we try to complete the square, because the process does not work unless it starts with a plain x squared. we have to make that start with the plain x squared. So to do that, I'm just going to divide everybody by whatever's in front of the x squared. In this question, it's going to be 3. Now, that's going to create a situation where we have a fraction, but it's okay. You can handle a fraction. I know you can do it. So this will turn into x squared plus, I'm just going to leave this as a fraction, 8 over 3x. And right now, I'm just going to go ahead and leave myself a little space to complete the square. The other side of the equation, 3 divided by 3 is actually 1, so that's a nice number. And I'm also going to leave myself a space to complete the square on the other side. Now, I don't think we had anything like this when we did completing the square the other day. So, still the b value. I'm just going to make myself a little space up here. Still the b value, which is 8 over 3. That whole thing divided by 2 squared. Right? Kind of garbagey looking. All right, now, are you guys okay? Okay, you could do this on your calculator. I'm going to show you how to do it by hand real quick. If you divide by 2, that's the same thing as multiplying by what? Half. Did you guys do like keep, change, flip? If you divide a fraction by a number, this would be 2 over 1, right? So I'm going to keep the 8 over 3, change that division to multiplication, and I just wrote 2 as 2 over 1. If you divide by 2, it's the same thing as multiplying by the reciprocal. So this would be straight across the top, straight across the bottom, don't need a common denominator, 8 over 6. So, and I could reduce that, so let me write that as 4 over 3. But what we're squaring there is going to end up being 4 over 3. That's what you're going to square. Now, do I write that process out when I do that? No. I just know that if I'm going to divide a fraction, 8 over 3 here, by a number 2, literally all that happens, the denominator gets multiplied by that number. Like I ended up with 8 over 6. So if I see something like that, I don't write all that out. I just go, okay, I know I'm going to multiply by a half, so it's going to just multiply the denominator of what you got on the top by that number. That's what's going to happen. And then I reduced it there to get the 4 over 3. Now, whatever you square, don't forget, that's going to be your factor. I'm actually going to square it to complete the square. So it would be 16 over 9. 4 squared is 16, 3 squared is 9. Whatever you squared, that 4/3, that's going to be my factor. So it's going to be x plus 4 over 3 in your factored form. And then, of course, you can do this by hand, but I like to use my calculator because I'm lazy. All right, so I'm going to do 1 plus 16/9, and then I'm going to hit my math enter to convert that to a fraction for me. So I got 25 over 9. And then I'm like, sweet, because those are both perfect squares. So we're going to take square root, both sides. Don't forget your plus minus. I'm going to move this up just a little bit. All right, so this is going to stay x plus 4/3. The square root and squared cancel each other out. Don't forget the plus minus. What's the square root of 25? 5. What's the square root of 9? 3. And then I'm further in love with this problem, which is a little extra, but it's true. All right, I'm going to move this 4/3, but I'm very happy to see that the other side is 5/3 because that means I've got a common denominator there. So I have negative 4/3 plus or minus 5/3. I don't have any i's, I don't have any radicals, so we can actually go ahead and add these lovely fractions together. So I'm going to split this into 2 pieces. I'm going to do negative 4/3 plus 5/3. When you have a common denominator, don't change the denominator, just going to add straight across the top. This would be 1, the denominator stays the same. So this is actually, one of our answers is just going to be 1/3. Okay, my other answer would be negative 4/3 minus 5 over 3. Now, straight across the top there, I'm just going to subtract negative 4 minus 5, negative 9 over 3, and then that actually reduces to be a nice number, negative 3. So my 2 answers there, 1/3 and negative 3. You do not have to write all that work out. I'm just trying to show you where I'm getting these answers from. And feel free, if you want to use your calculator for any of that, you are welcome to do that. Is anybody having a question? Yes, ma'am. Oh, that's a really good question. No, I would say that's not usually the case. You're totally right, though. Those are actually opposite reciprocals. If those were slopes, those would be parallel lines. But no, that I think that's just a fluke that happens in this case. That was really good to notice, though. Excellent question. Okay, now, this one, that's right. All right, here's what I'm going to do. I'm going to put the squared term and the term with the x, so the quadratic term and the linear term on the same side. To do that, I'm just going to take one step here real quick and add 8x. It's subtracted, so I'm going to add it to be on the same side with the quadratic term. So it's a little more convenient to complete my square. I'm going to leave the 1 where it's at. Now, first rule of completing the square. If you don't start with an x squared, you got to start with an x squared. So we've got to remove the 2. And to do that, I have to divide everybody on both sides so no one feels left out, right? We're going to divide everybody by 2. This is going to become x squared. Now, this is actually nice for us. That previous question I had 8 over 3. Here I have 8 over 2, which is actually just 4x, right? I'm going to leave a little space to complete the square. The other side, just 1 divided by 2. I'm just going to go ahead and leave that as a half. Okay, now, what would I add to both sides here to complete the square? 4, good. That throws people off a bit, right? Because I've got 4 divided by 2 squared, which ends up being 2 squared, which is actually 4. So, completely right. Whatever you square, I promise you that's your factor. So this should be x plus 2 squared. The other side, I have half plus 4, and I want to write that as a fraction. So that's going to be 9 over 2. Again, you could do it by hand or just do like, I'm going to do 1/2 plus 4. Don't judge that I'm doing that on the calculator. And I just did that math, enter, just to make sure. Now, the part that's a little bit trickier here that we did not have on the last question. When I take and get rid of that squared by taking the square root, unfortunately, on the right side of the equation there, the top is a perfect square, but the bottom is not. So we're going to talk about that in this question here. So square root and squared cancel each other out. This just stays x plus 2. I got to have a plus and minus symbol. Now, square root of 9, I could do that. That's 3 on the top. Square root of 2, I can't take the square. It's not a perfect square, so I got to leave the square root there. Now, we are not allowed to have a radical in the denominator. It's not considered simplified. Does anybody know how to get rid of the radical in that denominator? Yes. Okay, whatever is in your denominator, just multiply top and bottom by that. You do not need to do that on both sides. I'm just multiplying by 1, right? Radical 2 over radical 2, that's just 1. So that does not change the value of the expression on either side of the equation. So just right there. Okay, now this is going to be x plus 2 plus or minus. The top of that fraction would be 3 roots of 2. What would the bottom of the fraction be? 2. Okay, and if you're like, what the heck, where did you get that from? Psycho, just writing stuff down without explaining it. Okay, so the top right, you just straight across the top, straight across the bottom. The whole purpose of doing this is called rationalizing the denominator. When you multiply a square root by its exact same thing, 2 times 2, that will always create a perfect square. When you do that, you can always multiply radicals. And so 2 times 2 is 4. When you take the square root of 4 is 2, gets rid of the radical. So that's where the 2 comes from. It's the square root of 4. Now, to get this, so x is by itself, I'm just going to move this 2 to the other side. I was adding it, so we got to subtract it when we move it. So it'd be negative 2 plus or minus 3 roots of 2 over 2. Now, if you want to just do negative 2, you can. Go ahead.
You have to have the denominator.
You don't have to. Okay, if you wanted to just write negative 2, like I don't care about this, but just in case, I think the Math Excel wants you to write this as a single fraction, so I'm just going to show you how to do it real quick. I would need a common denominator. To do that, I would multiply the top and bottom by, just in case you have to do this. So be negative 4 over 2, right? That's equal to negative 2. To put that together, now they have a common denominator, the top of this is just going to be -4 plus or minus 3 roots of 2, the whole thing over 2. I know that's like a little complicated, and like I said, if we're doing a test or quiz, I'm cool with that step right way back there before I started to do anything else. But just in case the Math Excel, I think it might want you to write it as a single fraction. So I'm just showing you how to do that real quick. Is anybody having a question? Okay. Exciting news, a little word problem. All right. So I have a little rectangle pictured in the diagram. That's the first question on the back here. And it says the area of this lovely rectangle is 80 square inches. We want to find the value of x. All right, so in the diagram, they've just got labels. I've got a expression here, x minus 3, and I've got a 2x. If I was trying to find the area of that rectangle, and don't worry about what x is for the moment, but how would we maybe set up an equation if I'm trying to find area of that rectangle? Like, what would you do with the x minus 3 and the 2x? Exactly. So just like length times width, right? We're just going to multiply. So it'd be 2x times x minus 3, and then I would just go ahead and set that equal to the area that they give me. Okay. So I could let me go ahead and simplify that just a little bit, get rid of the parentheses. So, and I'm going to just write it underneath here. I get 2x squared minus 6x equals 80. What do I maybe notice right away about all three of the numbers there? Divisible by 2. So let's dispose of it. You can't do this with a variable, but if they're all divisible by a number, we're just going to go ahead and divide everything by that number. So I've got x squared minus 3x is equal to 4. Okay. Now, it says solve your equation by completing the square. So it's already kind of set up for us where I have the two terms I want on one side. So the x squared plus 3x plus, I'm going to leave a little space. And then that plain number, the 40, is already by itself on the other side. This is a little bit tricky because the b value here is 3. So anytime that number in front of your x is odd, you're going to deal with a fraction. So it's your b value divided by 2 squared. 3, I can't actually divide by 2, but I can square that. So square the top, square the bottom. Oh no, what did I screw up? There was like 3 hands that went up. Yeah. That's what I obviously wrote. You guys are just having vision issues. No, I'm just kidding. Sorry, this is a -3 fail. You have a terrible math teacher. I'm really sorry. Okay. I make too many mistakes. All right, so I'm going to add 9 over 4 to both sides. This is a minus. Pretend I wrote that correctly, which I totally did not. All right, now I swear to you, whatever you square, that's what goes in the parentheses with the x. So this will be x, this would be negative. I also screwed that up. Okay, so minus 3 over 2 squared. Now, you of course could do this by hand. I'm just super lazy. I mean, using my resources. I'm going to add 40 to 9/4. I'm going to hit math, enter, and it's going to give me lovely fraction in lowest terms, which is going to say 169 over 4. Then I'm super excited about that because I know those are both perfect squares. Okay, so what have we got? X minus 3 over 2. Don't forget your plus and minus. Do you guys know square root of 169? 13, yeah. And then square root of 4 is 2. Okay, so my two options here, I'm going to add that 3 over 2 to get it away from the x. So 3 over 2 plus or minus 13 over 2. Okay, 3 over 2 plus 13 over 2 would give me 16 over 2, which is just 8. You don't have to write all that out. I'm just trying to show you where it comes from. So one of my answers is 8 for that equation. My other answer, 3 over 2 minus, because it was plus or minus, so the minus 13 over 2, that would give me 10 over 2, which would be -5. Now, which one of those is actually the answer to the question? Why not the -5? You cannot have it. We're talking about a length. If I plugged in -5 into that rectangle, we would have negative dimensions, which you cannot have. So just the 8 is the answer there. It just asks for x. It doesn't ask for the dimensions. But if you wanted to plug that back into the expressions they got in that picture, you could do that to tell me the dimensions of the rectangle if you wanted to check. But 8 should be the answer. -5 not, because we can't have a negative length. Okay. Now, the last thing I have to show you today. I have to show you how to convert standard form into vertex form. We did this in our last unit. I did not do completing the square for that. I just showed you to do -b over 2a, which you could still do. But I do need to show this to you because this is a really important thing that you guys will use in the next couple of classes after this. You got to know how to do this process. Okay, so just to remind you, the vertex form of a quadratic is just a little bit different than what we've been dealing with. That is the y equals a times x minus h squared plus k. hk is going to be the vertex. Okay, I'm going to show you how to take standard form and use completing the square to put it in that format. Okay, now different people do this different ways. So I'm going to show you the easiest thing I have done for myself. Okay, I have a y here instead of a 0, so it's just slightly different than completing the square like we would for solving an equation. What I would tell you to do though, put any plain number to the other side with the y. So what I'm going to do, I'm just going to have y minus 5 equals x squared plus 8x. That's how I would start that out. And I probably should have done this. I'm going to complete the square. So I'm just going to leave myself a little blank to fill in that number that would create a perfect square trinomial there. So maybe just ignore this side for a second. I'm going to say x squared plus 8x, turn this into a perfect square trinomial. What would I do to get that number here? Or who could tell me what the number would be? Yeah. Perfect, 4 squared, so 16. Okay, now, if I do something to one side of the equation, I have to do it to the other. If I'm adding, subtracting, multiply, and divide, so I'm going to add 16. Okay, now over here, just -5 plus 16 is 11, right? So just have y plus 11. Now, what we've done here, we got a perfect square trinomial, so my two factors are the same, so I can squish them together. So multiply to get 16, add to get 8, 4 and 4. I swear to you, whatever you square is your factor. So this will be x plus 4 squared. Now, I'm trying to make the equation look like this, the vertex form. Literally, all you got to do, just move the 11, and it's just going to be subtracted kind of to the end of, on the other side of the parentheses. So this would be x plus 4 squared minus 11. And there we just transformed the standard form into vertex form by completing the square. See if you guys remember this. Okay, maybe raise your hand, tell me, what would the vertex be? Do you remember figuring it out? Yes. Opposite, whatever's with the x, copy whatever's outside, that's your y. So -4, -11 would be my vertex there. I know that's a little weird. Is anybody having a question? These other two are going to be a little bit harder. So that one we just worked on started with an x squared. These other two are not. All right, so again, first thing I would tell you to do, if you got a plain number, constant term, just move it to the other side with the y. So I'm going to add 7 to do that here. Okay, now, just as I set this up, I'm going to put plus and leave a little blank space for myself to complete the square. Okay, now here's the deal. On the other side, I am going to grab a different color real quick. I can't have anything in front of my squared term. What I'm going to do, and I'm just going to do it to those two terms, the 3x squared and the -12x. I'm going to pull a 3 out in front. I know this is kind of weird. So I'm not dividing it by everything on both sides, but this is the fastest way I can get you there. So I'm going to take those two terms and get rid of a 3. So left over I'd have x squared. If you take that negative 12 divided by 3, that would make that negative 4. Okay, I'm going to leave a little spot to complete the square, and that whole thing is going to be in parentheses. Okay, what would you put in here to complete the square? Don't worry about the 3 out in front. Just pretend that I gave you x squared minus 4x. What would you add there? 4. Okay, I was about to have a heart attack. Okay, your b value divided by 2. So negative 4 divided by 2 squared, negative 2 squared. Okay, now let me ask you this question. I pulled a 3 out in front of both of those terms. What did I really add to that side? 12. Does that make, like, I got a 3 out in front here, so when I put that 4 in there, I really added 12. Does that make sense? Okay, so what I'm going to put over here is 12. Because I had to pull that 3 out in front because we didn't start with the plain x squared. So and I didn't have to do that in the last question because it started with the x squared. This one had a 3x squared, so that's why I had to pull that out in front. Now, this would just become 19. This would have a 3 in front of your squared. So this is going to be x minus 2 squared. Then all I have to do is move the 19 to the other side of the equation. And then you got it in vertex form. So you got 3, and that's your a value. Remember, a value is the same in both forms. There's your 3, there's your 3. X minus 2 squared minus 19. That's vertex form, that same exact equation. What would you tell me the vertex of that quadratic is? 2, negative 19. Okay, now I'm going to do one more with you. Each one of these is just a little different. I'm trying to think of everything I thought you could run into. All right, so I'm going to do the same thing I just did. Take any plain number and move it to the other side with the y. So I've got this plus 3 here, so I'm going to subtract it. So I'm going to have y minus 3. I'm just going to go ahead and write a step here. You're going to have negative 2x squared plus 10x, because I think I confused people when I just took that 3 out just now. Okay, now I'm going to complete the square. So I'm going to leave myself a little space to add whatever I'm going to complete the square with. Now on this side, what I have to do, and I can just do it on this side, I'm going to pull whatever is in front of your x squared out in front. Now, because this has a negative 2 in front of the x squared, I'm going to pull out a negative 2. This will change this to positive x squared. Now if I do 10 divided by negative 2, this is minus 5x. And then I'm going to leave myself a little space to complete the square. This one's a little trickier because I've got a b value that's an odd number. All right, so take negative 5 divided by 2, so the b value divided by 2 squared. I cannot actually divide that. So what I'm going to do is just square both parts of this. This is going to become positive 25 over 4. So 25 over 4. Now, what I got to ask myself, because I had pulled this number out in front, like what did I really add to that side? And so I'm like, I don't know. So I'm going to take, I'm really adding whatever negative 2 times 25 over 4 is. And so I'm actually subtracting something from this side because of this being negative. So what I really put in here is negative 12.5. Let me just convert that to a fraction real quick for us. So this is negative 25 over 2. I just converted it to a fraction just real quick. If you wanted to use the decimal, I personally would not care, but I think on the Math Excel it wants you to use fractions. All right, and it's a subtraction because this is negative, that's why. So I'm going to take negative 3 and then minus that 25 over 2, just using my calculator to help speed this up. So that would simplify to be negative 31 over 2. Over here, just keep that negative 2 out in front. Whatever you squared, I promise you that's your factor. So it's x minus 5 over 2, all that being squared. And then I just have to do one more thing and I'm done. I'm going to add this 31 over 2 to the other side. And so my vertex form would be -2. That's your A value, same in both forms. X minus the X coordinate of the vertex, and then Y coordinate of the vertex is on the outside. So if they ask you for your vertex, we're just going to do opposite copy. So it's going to be +5/2, and then 31/2 is the Y coordinate. Is anybody having a question?